We have seen how JUnit Jupyter can solve a lot of use cases for parameterized tests with its built-in source annotations. However, the framework maintainers couldn't possibly support each and every single demand that could arise in a developer's codebase. Every application is different after all, and so may be its requirements for elegant testing. Luckily, for advanced users, the APIs driving the declaration of parameterized tests are opened up, so you can write your own source if necessary. Now again, this is for advanced users, but I'd still like to explore this. Our goal is to implement a source that can understand JSON arrays and pass a deserialized JSON node to a test method. For the sake of simplicity, I will rely on the JSON databind library for this example to do the actual parsing, but this is just for demonstration purposes. Any other means of parsing JSON would work just as well. We will need a custom source annotation as well as an arguments provider that reads the annotation's data and then resolves the parameters of a test for the engine. Now, let's assume that we have built everything already, just so that we can have the finalized desired API in mind for this feature. We have our test method, which will receive a JSON node object. This object will be provided through the custom source. Next, we attach the annotations to the method, starting of course with add_parameterized test, and then our custom annotation, add_JSON_source. The way I imagine people using this is that the annotation should get a value called text, which is the string representation of the JSON array to parse. Let's fill in some data and write out the body of the test. The next step in the implementation is providing the annotation class itself. Thanks to the wonders of Kotlin, this is just a one-liner, and we make sure to add the text argument as well. To achieve a more polished user experience in our IDE, let's also annotate this with JetBrains' add_language annotation, so that we get some cool syntax highlighting. Neat. The important part, connecting this arbitrary annotation to Jupyter, now comes with the meta annotation on top of this annotation class. Finally, the last step of the way, the arguments provider itself. It will read from the add_JSON source annotation and convert its contents into a stream of arguments, which Jupyter then provides piecemeal to the test method. We implement the arguments provider interface, which contains just a single method. But wait, now how do we access the value written inside the JSON source annotation? The extension model of JUnit 5 provides a handy way to consume annotations for classes that require external input. We will make our JSON arguments provider implement another interface. It's called annotation consumer. This is a generic type that the test engine will feed the annotation's value to. Basically, we register our provider to consume our own annotation, and this new method is where we pull out the data from the annotation. Let's store it inside a variable so it's accessible from the other guy. Now we are ready to implement the provideArguments method. In the JSON library, this is the API to convert a string into a tree of JSON objects. The last thing to do now is convert this JSON node into a stream of arguments, honoring the return type of this method. So we first use Kotlin extensions to create a list from the parsed JSON, then we convert that into a Java 8 stream, mapping each item in the list to JUnit's arguments type. That was quite a bit of work, but we did it. We effectively wrote a new feature for JUnit Jupyter, and we made the test engine just that tiny bit smarter to understand arbitrary JSON input with just 2 tiny classes. When I execute this parameterized test now, each item in the JSON array will get its own invocation, and the assertions in the test can use the inputs to validate whatever it is that they want to validate.